Today in this video we will study about chip thickness ratio. What is chip thickness ratio? Its definition, terms related to chip thickness ratio, their formula and derivation. Let's look at the definition of chip thickness ratio. Chip thickness ratio is defined as the thickness of metal before cutting to the thickness of metal after cutting. Now let's see the diagram of the chip thickness ratio. This is the workpiece, this is the tool. This is the chip after cutting, and this is the T1, which is the thickness of chip before cutting, and T2 is the thickness of chip after cutting. Now let's see the formula of the chip thickness ratio. Now let's see the formula of the chip thickness ratio using the diagram. This is the diagram. Now we know that T1 is the chip thickness before cutting and T2 is the chip thickness after cutting. So the chip thickness ratio will be T1 by T2. One thing is to be noted that whenever there is high cutting ratio, it means the cutting action is good. That means that is if T1 is greater than T2, the cutting action is good. Now let us assume different parameters. Now let L1 equal to length before cutting, L2 equal to length of chip after cutting, B1 equal to width of chip before cutting, B2 equal to width of chip after cutting. Alpha equal to rake angle of tool, beta equal to shear angle. Now as we know, let the volume of the workpiece before cutting is equal to the volume of the workpiece after cutting. In other words, we can say that the volume of metal cut off from workpiece is equal to the volume of the chip. So L1 B1 T1 equal to L2 B2 T2. T1 and T1 and T2, as we know, are the thickness of chip before and after cutting. Moving on to the next slide, and now we generally have B1 equal to B2, which means breadth of chip generally doesn't change while cutting. So therefore T1 L1 equal to T2 L2, or T1 by T2 equal to L2 by L1. Then the chip thickness ratio R equal to T1 by T2, which is equal to L2 by L1. And now we will see chip thickness ratio in terms of alpha and beta. From the diagram we have T1 equal to AB sin beta, which is equation number 1. T2 equal to AB cos beta minus alpha, which is equation number 2. Then then we know that R equal to T1 by T2. From 1 and 2 we have R equal to AB sin beta by AB cos beta minus alpha. This is the equation of chip thickness ratio in terms of alpha and beta. Now we will see about the shear angle, which is beta. Let's see its definition. Shear angle. As the tool is pushed into the material, the chip is formed by shear deformation along a plane called shear plane. which is oriented at an angle with the surface of work known as shear angle. It is denoted by beta. From equation number 3 we have, from the last slide we have r equal to sin beta by cos beta minus alpha. R cos beta minus alpha equal to sin beta. Then breaking cos beta minus alpha with the formula cos A minus B, we have r into cos beta cos alpha plus sin beta sin alpha equal to sin beta. Then r cos beta cos alpha equal to 1 minus r sin alpha sin beta. Taking sin beta to the other side and r cos alpha to the right side, we have cos beta by sin beta equal to 1 minus r sin alpha by r cos alpha, which gives tan beta equal to r cos alpha by 1 minus r sin alpha. This is equation number 4. And this is the formula to find shear angle. Now we will see the factor on which chip thickness ratio depends. There are mainly 4 factors. Number 1 is type of material. Second is type of cutting fluid. Third is geometry of cutting tool. And fourth is cutting variables such as feed rate and speed depth. Now we will see numericals on chip thickness ratio. Calculation of chip thickness ratio and shear angle. So here is the question. In a machining operation of orthogonal cutting, the cutting tool rack angle is 10 degree and chip thickness ratio before cutting is 0.50 mm and after cutting is 1.125 mm. Calculate the chip thickness ratio and shear plane angle. Now let's look at the solution. Here are the given data. Alpha equal to 10 degree. This is the rectangle. Chip thickness before cutting T1 equal to 0.50 mm. Chip thickness after cutting T2 equal to 1.125 mm. As we know that chip thickness R equal to T1 by T2. So R equal to 0.50 by 0.125. So chip thickness R equal to 0.44. So the chip thickness ratio will be 0.44 and it will not have any unit. Now as we know, tan beta equal to R into cos alpha by 1 minus R sin alpha. So putting the values, we have tan beta equal to 0.44 into cos 10 by 1 minus 0.44 into sin 10, which gives tan beta equal to 0.4691. Hence shear angle beta will be equal to 24.13 degree. That's it for today. Thanks for watching this video. If you have any question, you can ask in the comment section, and if you like this video, share it with your friends.